Then we come to the Internet of Things. How many of you have heard this term? Okay. I mean, it's just absolutely amazing. So first off, you've got to think about, well, what's a thing if we're going to talk about the Internet of Things? It can be a person with a heart monitor implant. It can be an automobile that has built-in sensors to alert the driver when tire pressure is low. Any other natural or man-made object that can be assigned an IP address and provided with the ability to transfer data over the network. So that last bullet is important. So again, it's got to be able to have an IP address, and it's got to have some form of wireless communication. Otherwise, in this definition, it really can't be a thing, because it's got to be able to communicate with other people and or other machines, other devices. And how can we handle so many devices with so few 32-bit IP addresses? Well, we no longer have just 32-bit IP addresses. So we have IP version 6 uses a 128-bit address. So allowing 2 to 128, or approximately 3.4 times 10 to 38 addresses. So mathematically, that means we could assign an IPv6 address to every atom on the surface of the Earth and still have enough addresses left over to do another 100 plus Earths. In other words, humans could easily assign an IP address to everything on the planet. And I'm sure you all, there's a new CSI show. I don't know if any of you have seen it, but Cyber CSI. So I watched that just to listen to some of the buzzwords. And the other day, they talked about the bad guy had developed some code which would hack into printers and disable the thermostat, causing the printer to overheat. And then it would be fed paper, and the paper was the fuel, thus causing fires. So, thanks to those kind of criminals, we now have cybersecurity with a great demand for people. So the impact of Internet on Things to the world. McKinsey Global Institute. They anticipate an economic impact of 2.7 trillion to 6.2 trillion annually by 2025. Gartner, 26 billion devices on the Internet of Things by 2020. ABI Research, more than 30 billion devices will be wirelessly connected to the Internet of Things by 2020. I know a lot of people that get frightened at this thought. I know a lot of people that get excited by the whole Internet of Things. I'm one of the ones that I get excited. I mean, it presents a lot of opportunity for us. So from a testing perspective, what do you think some challenges might be? Anybody have a guess?
The sheer volume of interfaces is enormous.
I'm sorry, say about interfaces? Say that again, please.
The sheer volume of interactions that happen, the possibilities are huge.
Excellent point. The sheer volume of interfaces and the volume of activity that happens can be overwhelming. What else might be a challenge? Excuse me? I'm sorry, one more time. Oh, confidentiality. That's a great point. So not only do you have, from testing it, you've got to be careful about data, but you've got all these government regulations, I'm sure, that you have to be careful about, right? So let me take a common device that I'm sure a lot of you are familiar with. My wife wears hers religiously, and that's the Fitbit. How many of you have a Fitbit? See, a lot of you guys do, and you just don't want to admit it. But so with the Fitbit, think about that for a moment. Imagine that you've got a requirement that says, let's validate that our Fitbit can work in sub-freezing temperatures when worn by a moderate athlete that can run 5 miles. So let's talk about that for a minute. So how are we going to test that? So, you know, can we do automation? Well, maybe, but do we really want to bear the expense of building something that can automate running 5 miles? So now you've got to do what's called testing in the wild or field testing. So we'll talk about that in just a minute, but you truly have to rethink the whole process. Sensory monitoring adds innumerable and minute variables to the testing process. Because these smart devices that we're talking about, they can, just with a Fitbit and other devices, they can monitor your pulse, your respiration, your body temperature, etc. How do we simulate the real life scenario? So back to the Fitbit scenario of running 5 miles. I mean, basically, you've got to have a test subject. Somebody that you would classify as a moderate athlete that can run 5 miles in sub-freezing temperatures. Testing will move out of the lab and into the wild where poor connectivity and imperfect conditions are the norm. A lot of the devices that they're creating are, you know, they're meant to truly be used anywhere. So that's something that you have to take into account. And then you have to think, how are we going to emulate that? Test subjects may be needed, as I mentioned, and testing in the wild or field testing is focused on getting the UX right. So UX, common acronym for user experience. So you want to do real-world testing. So when it comes to the Internet of Things, those types of applications, these are just some of the testing challenges that you're going to be faced with. But, you know, for all of those, especially for the Internet of Things, I mean, we're starting to see more of a demand for that just because of the challenges that it's introducing to software testing.